Hi, through this video we will learn the concept of surface tension, and we will learn the concept unit of surface tension, and we will try to determine the pressure inside the droplet, pressure inside a bubble, and pressure inside a water jet. Surface tension is the concept of liquids that in which the liquid surfaces act as stretched membrane. The cohesion causes the liquid molecules to remain attached to each other, whereas due to adhesion, the liquid molecules get attached to the surface they come in contact with. Suppose this is the liquid. A particle in the interior is surrounded by other particles all around, whereas a similar particle on the surface is surrounded only in these directions, not from the above. If we view it from the top, along this line of length L, all the particles are being attracted in this direction from the particles all around. Suppose this force of attraction is F. Then the surface tension is defined as F by L, that is force per unit length. So it is represented by lambda. So accordingly its unit is Newton per meter. So these are the values of some common liquids at 20 degrees Celsius. The point to be noted over here is the surface tension is the concept of liquid surfaces only. Let us consider the pressure inside a droplet of diameter d. The pressure inside the droplet is trying to split this droplet into two halves along this dotted line into these halves. And the force of surface tension is trying to oppose this split, which is acting in this direction. If you view it differently, this droplet when split into half appears like this. The pressure force is pressure multiplied by the area pi d squared by 4, which is this shaded area, and it is being opposed by the force due to surface tension, which is lambda multiplied by the length of this red line, which is length of the surface, which is pi d, perimeter of the surface. Same is the case with the second half. And for equilibrium, these two forces, pressure force as well as the force due to surface tension, should be equal. And if we equate them, we get pressure inside the bubble, inside the droplet is equal to 4 lambda by t. If we consider pressure inside the bubble, this is the case. In the similar manner, this is the half of the bubble which is split. The pressure force remains the same, pressure multiplied by the area of cross section, which is pi d squared by 4, but the force due to surface tension is doubled. It is twice of lambda multiplied by pi d, because in this case there are two surfaces, one is from the outside of the bubble and one is from the interior of the bubble. Same is the case with the second half. So in case of equilibrium, these two forces will be equated, and accordingly we will get the value of pressure as 8 lambda by t. Now considering the pressure inside a water jet, suppose this is the nozzle from which the water jet is coming out. The diameter of the water jet is d, and let us consider a small length L of the water jet, and the pressure inside the jet is trying to split it into two halves along this dotted line. So considering one half of that split, it appears like this. The diameter is d and the length is L. The pressure force is P multiplied by the shaded area, which is L into d, whereas the surface tension force is acting along only these lines, that is lambda into twice L, because there is no surface tension available along these two lines of the diameter, because this is a continuous water jet and no free surface is available at these lines. Equating these these forces, the pressure inside the jet comes out to be twice lambda by t. Now at the end, let us compare these values. The pressure inside the droplet is 4 lambda by d. Pressure inside the bubble is 8 lambda by, which is double the pressure inside the droplet. And pressure inside the jet is just half of the droplet, that is twice lambda by t. Thank you.